We, people, like to flaunt that we are the pinnacle of creation. And, to be sure, there is no question that our species has accomplished numerous noteworthy achievements throughout its existence. However, do these human accomplishments imply that we are capable of interpreting the world entirely around us? The unmistakable response to this question is no, quite the opposite. Some observations and expert theories do not result in enlightening realizations but rather disconnected conundrums, causing headaches for quite some time. If extraterrestrial life exists, why have we still not identified it? Why is the night sky dark despite its millions of stars? And what glaring inconsistencies are associated with time travel? Want to know what the experts have to say about these key research mysteries? Then be sure to watch today's video all the way to the end. Would you like to learn more about the greatest secrets and exciting discoveries in the universe on a regular basis? Then click the subscribe button, hit the notification bell, and become part of the ultimate space community. Feel free to show us your support with a thumbs up so we can keep you engaged with the content of our videos. Fermi Paradox. Before we can maintain the fundamental belief that extraterrestrial intelligences exist and that they are capable of sustaining their civilizations for extended periods, a crucial question arises. Where are the aliens? If they're really out there, our extraterrestrial counterparts should have succeeded long ago in interstellar space travel and spread across the Milky Way. This proposition was first introduced by Italian physicist Enrico Fermi in 1950, and it still fascinates experts since we have yet to detect extraterrestrial life. Experts are exploring alternative ways to resolve the Fermi Paradox. The first explanation dismisses the question entirely. According to the rare Earth hypothesis, the emergence of terrestrial life represented a unique process based on a series of highly improbable events. Those who don't believe we are alone in the universe attribute the paradox to the massive distances within our galaxy. According to this view, colonizing the Milky Way wouldn't proceed uniformly but would result in bubble-shaped clusters with delineated catchment areas. Other experts address the question, if they exist, why aren't they here? With the idea that extraterrestrials may have already extinguished themselves. Stephen Hawking believed that a species' technological prosperity is often tied to great risks. At some point, unbridled advancement could lead to internal instability, inevitably resulting in the collapse of the affected civilization. Possible triggers include nuclear wars, genetically modified organisms, or runaway greenhouse effects. The Great Filter hypothesis builds on this notion, suggesting that civilizations must overcome a series of obstacles on their way to technological supremacy. Some extraterrestrial societies might fail at certain intermediate stages of this filter and perish before achieving interstellar space travel. For instance, consider the development of our own species, from simple microorganisms to primates, to a community capable of launching artificial spacecraft into space. Obstacles had to be overcome at every step. We might also be fortunate that we have not yet come to the attention of our unknown neighbors. The terrifying dark forest hypothesis suggests that the dominant civilizations of the Milky Way are not interested in peaceful coexistence. Instead, to secure their supremacy, they eliminate potential competitors. These entities may send lethal probes to neighboring systems. Consequently, most civilizations might do best to remain undetected for as long as possible to ensure their continued existence. In this regard, the Milky Way might resemble a dark, dense forest. Those who do not wish to be hunted must remain hidden. Far less troubling is the explanation that extraterrestrials might simply not be interested in us. When considering that a civilization is theoretically capable of communication or interstellar travel, would it necessarily view such an endeavor as worthwhile? Given the economic and logistical challenges such a mission would entail, some experts believe the answer is no. Olbers Paradox. The view of the starry night sky is absolutely mesmerizing, but have you ever wondered why the night sky is dark despite its countless shining stars? Given that the universe is an infinitely vast construct, you might assume the distribution of stars would appear uniform across great distances, causing the night sky to glow as brightly as the surface of a star. This apparent contradiction was first explored by German astronomer Heinrich Wilhelm Olbers in 1823. Over the years, numerous solutions to the night sky paradox have been proposed. For example, some experts hypothesize that the light from distant stars is obstructed by dust and gas. Fortunately, today we understand the true cause of this cosmic mystery. Despite Olbers' assumption, it is not possible for us to observe infinitely far into the universe. The observable universe represents only the portion of the cosmos from which light has reached us since the Big Bang. Additionally, Olbers overlooked another crucial factor: the finite lifetime of stars. This further limits the number of celestial bodies whose light can reach our eyes. We humans like to flaunt that we are the zenith of creation. To be sure, there is no question that our species has accomplished numerous historic achievements over the course of its existence. Yet, do all these human accomplishments imply that we are close to unraveling the world completely around us? The unmistakable answer to this question is no, quite the opposite. Some observations and expert theories don't result in enlightening realizations but instead lead to puzzling conundrums, causing headaches for many. For example, if extraterrestrial life exists, why have we still not detected it? Why is the night sky dark despite its countless stars? And what paradoxes would time travel entail? Want to know what experts have to say about these key research mysteries? Then make sure to watch today's video all the way to the end. Would you like to learn more about the greatest secrets and exciting discoveries in the universe on a regular basis? Click the subscribe button, ring the notification bell, and become part of the Simply Space community. Don't forget to show us your support with a thumbs up so we can continue engaging you with the content of our videos. The Fermi Paradox. Before we can maintain the fundamental belief that extraterrestrial intelligences exist and that they are capable of sustaining their civilizations for long periods of time, a crucial question arises: where are the aliens? If they are indeed out there, wouldn't our extraterrestrial peers have succeeded long ago in interstellar space travel and spread across the Milky Way? This suggestion was originally presented by Italian physicist Enrico Fermi in 1950, yet it continues to captivate many experts. Since we still have not succeeded in detecting extraterrestrial life, researchers are looking for alternative ways to unravel the Fermi paradox. One explanation invalidates the topic altogether from the start. According to the rare Earth hypothesis, the emergence of life on Earth was a unique process based on a series of highly improbable coincidences. Those who don't believe we are alone in the universe, however, attribute the paradox to the vast distances in our galaxy. According to this perspective, the colonization of the Milky Way would not proceed uniformly. Instead, bubble-shaped clusters with distinct catchment areas would form. Other researchers answer the question: if they exist, why are they not here? By proposing that advanced civilizations may have destroyed themselves long ago. Stephen Hawking also believed that technological advancements are often associated with great risks. According to this view, unrestrained progress could eventually lead to internal instability, inevitably causing the collapse of the affected civilization. Possible triggers might include nuclear wars, genetically modified pathogens, or uncontrolled greenhouse effects. The Great Filter hypothesis suggests that civilizations must overcome various barriers on their way to technological mastery. Some extraterrestrial societies might fail at certain intermediate stages of this filter and perish before they achieve interstellar space travel. Consider the development of our own species, from the simplest microorganisms to our primate ancestors to a community that now sends humans and artificial spacecraft into space. Numerous obstacles had to be overcome. However, we might also be lucky that we have not yet been noticed by our unknown neighbors. The dark forest theory. The terrifying dark forest theory suggests that the dominant civilizations in the Milky Way may not be interested in peaceful coexistence. Instead, they prioritize securing their supremacy and eliminating any competitors. These beings might send death probes into neighboring systems to ensure their dominance. As a result, most civilizations would be wise to remain undetected as long as possible to guarantee their continued survival. In this context, the Milky Way could be compared to a dark jungle, where those who don't want to be targeted by predators would do well to remain hidden. Indifference or disinterest. A less unsettling explanation proposes that aliens are simply not interested in us. If a civilization were theoretically capable of interstellar communication or travel, would it necessarily see such an endeavor as a worthwhile goal, given the immense economic and logistical efforts required? Some experts think not. Olbers Paradox. The sight of the brilliant night sky is absolutely breathtaking. But have you ever wondered why the sky is dark despite its countless stars? Given that the universe is infinitely vast, you might expect the distribution of stars to appear uniform over great distances, so that their light would have already reached us from every direction. Logically, it would seem that the night sky should shine as brightly as the surface of a star. Even the German physician and astronomer Heinrich Wilhelm Olbers pondered this apparent contradiction in 1823. Over the years, various solutions to the night sky paradox have been proposed. For example, some experts speculated that the radiance of distant stars is obscured by dust and gas. Fortunately, today we understand the true cause of this cosmic mystery. Despite Olbers' assumption, it is simply not possible for us to see infinitely far into the universe. The part of the universe visible to us is called the observable universe. Since the Big Bang, only light from a finite region could have reached us. Additionally, Olbers dismissed another critical factor. The lifetime of stars is finite, further limiting the number of stars whose light can reach our eyes.